Hi, we're here today to look at four-piece transition. So we got our shop drawing drawn up on the board, and I got an example here, just a four-piece. So this one is something like that. Okay, flat on top. Ours is flat on bottom, but our bottom is the back side here from what we see. Okay, so if we looked at this one where it's flat here, ours would be looking this way on it. Okay, but four-piece transition is just a rectangular duct fitting that is changing in size, and it could go either way, right? So from what we got here, we got our opening size 18 by 12 going to 13 by 8 over length 12 inches. It's indicated as flat on bottom, and we got another offset here of 3 inches. So we could work this from this view, but I'm gonna show you the way I like to do it from what is an end view. But I want to look at what sort of indications we might see inside here. Okay, we have flat on bottom. We could also have flat on top. Okay, we may see that one. We may see a CF, which is center flare, which means that it's equal in both planes. The top, what would be the top here, and the back side, bottom, would be transitioning equally. We could also have indications where it's maybe up 3 going in that direction, or that could also be down 3 going in that direction. So again, slope that way, slope this way. So look for the clues inside here of what that fitting is doing. Okay, we're going to leave ours flat on bottom, which means again that back side that we don't see there is going to be flat. Okay, so like I said, the first thing I like to do is get a representation. I want to see looking through it, and I find that's the easiest in a couple of ways. I like to figure out how many pieces it is from that view, and then I like to label and look at what the parts will look like from an inside view, which is the way I'm going to lay them out. I like to see that from an end view. Okay, so let's just sketch a few here before we actually get into this fitting itself. Let's just sketch a few and go over some of the parameters that we look at. So if we had an end view and we got a piece of duct here, or an opening, and let's say that it was just a piece of duct, and if I did that, I would overlay. I would have another piece laying right over top of it here. So if I hold up a piece of duct, I look straight through it. Okay, and what that shows us is, because the lines lay on top of each other, the corners all end up being dots. I can see when the front end and the back end land right in front of each other, it appears as a dot here. And when something appears as a dot in that end view, it means we can bend it. So think of that ductwork and those ends being in line with each other. That means I can bend. There's no transition or change there. Okay? So I get 4 dots in a piece of duct. If I go with a 2-piece transition, and let's say it's flat on bottom, I'm gonna see something like this. So the back end or the front, it doesn't matter which way end you look at it, but one end is much taller than the other. Okay, and then the width is staying the same. So in this case, we got 2 dots here. And then the line that joins the 2 ends is going to be this one here. So we'll see that. We'll see that in that end view. But being that we have 2 dots, it means we can make one piece as a wrapper, the U-shaped piece, and then the top goes on it. With 2 bends, that means I can have 3 sides, or 2 sides in the bottom, all together in one piece. Okay, so these dots help me configure which is it, 1 piece, 2 piece, 3 piece. we get into a little more complicated of a fitting, we may see something like that. Okay, and then we don't have any overlay and we don't have any dots. We have lines for all of these. So that's, we could say it's all equal, but something even like a hopper. Just four sides to that taper. It's going to be 4 pieces because we don't have any dots. The dots tell us that it's a bend. Okay, so that's our starting point. We've got to figure out how many pieces it is, and we're going to label it from there. So let's get rid of that one. And let's draw this one here. So let's actually just draw it. I'm going to use the ruler and draw it full size. So 18 by 12 to start us off. So I always start out with my largest end, and I just draw that the way I see it. So I'm 18 here, which I see in my view of my fitting, and I'm 12 across here. Okay. Now I want to have something that it gives me what's called a datum point, something to reference everything else from. Okay, I need some sort of a starting point of where the second end configures with this one. Okay, and I got a few spots to start, but I know that I'm flat on bottom. Okay, and remember that was the back side. It's not really the bottom. This could be the bottom here, but really in ours, it's the back side of what we're viewing. So if this was my piece here, and I've spun that around to here, this back side where my finger is the bottom. That references back to my left side here. So I know that I'm flat against this edge here. Okay? I know that I'm down 2 for that offset, and I'm up 3. So I put a tick at 2, and I put a tick at 3, and I'll run these across. Okay, so that can be sort of our starting point, right? And now I can just measure my second dimension, which is going to be my 8, and then square this up and get my fitting. Okay, again, you're going to use construction lines so that everything is nice and faint. You don't want to see these extra lines, and you don't want to have to erase them. So go in and do it nice and faintly. And then with my straight edge, I'll connect those corners. Okay, so I see that in each one I have a red line that connects one end to the other. And that tells me that they're all 4 independent pieces. So this particular fitting is going to be 4-piece. Okay? Now, what we want to do next is I like to go in and label things according to how much slope they have. Okay, so I know this side here is 0 because it's flat. So I label it S, and then a sub-label of 0, the amount of offset it has. This part here, I'm going to call it top, and the top comes down 2 inches. Okay, the back side is going 5, so the other side here is a 5. And then our bottom is 3. And even though you can see that in this view I called the back side here the bottom, and now I'm calling this the bottom, it's not a reference to each other. We're not saying that this is that one. it depends on which view you're looking at as to where those bottoms are, right? And this to me just makes sense as the top and bottom and the two sides. But this was our bottom where we're flat, right? So that labeling can shift around a little bit. Okay, so let me just add one line in here because just to get a little more clarity. Okay, from there, we can go in now and we can start calculating our blank sizes. Okay, so I can see that I can see the widest width of each one is going to be the green along that side. And where I'm going to go, I know that, you know, the S0, let's start a list here. I know that each of the slopes that the particular part is on is indicated by my sub-labeling here. And that's the number I'm going to use with Pythagoras against the first length I was given to calculate out the slope of it. So this part here, which was this one here, we know that we're 12 and 2. So my 2 is already here. I know which one's that going to be. Okay, so I'm just going to label those all out. And that'll be my list for blank sizes. Okay, so I know that 12 squared plus 2 squared is going to have to go into my numbers here for the length of that part. Okay. My other dimension is going to come from the green as the largest of the two. And in this, we're just going to call this one welded fitting. If you have connections, S and drive or anything like that, those will be additional as you've learned previously. So let's look at this one's going to be 18 by a length of 12 because there's no slope there. Okay, the top is going to be 12 inches total across here, and 2 squared plus 12 squared gives us 12 and 3/16. For side 5, we got, again, 18 by 5 squared plus 12 squared gives us 13 inches. And our bottom, again, we're 12 inches here by 3 squared plus 12 squared is 12 and 3/8. So there's all our blanks. We're ready to go. We can start shearing those up. One thing we want to touch on before we do that, and again it goes back to our end view here, is when we lay out anything, we always want to lay out to the inside. We don't want to have scratches and layout marks on the outside of a part. So we want to always do everything we can to get to the inside. So even though we're ready to go shear these now, let me get these out of the way. And we're just going to come back to this view here a bit. Now, what I have to look at in this one is unfolding the whole thing. So we're looking at this part like this, and it's got tops and bottoms and sides, and we want to unfold it all. And if we can sketch that, we're going to get what those parts all look like as the inside. So from this one, if I flip it on the green, on the big side, I know this one has to go from the width of the green, it's going to go some length, and then end up as a straight line here and a curved line, or not a curved line, an angled line on this side. So this will come up like that. So I'm taking that and rotating it back down. The bottom is going to look just the same. But a mirror. It's going to be the opposite of it. This side, again, we're going to start at the green, so it's going to be this width. It's going to come some length and then be at the orange width here. So it's going to be in here somewhere with 2 angled lines to get back to that size. And same on the side, we start on the green. We know we have to get down to this width. We've got 2 angled parts, so these are going to both come in like so. And there we go. So it gives us a good representation of where some square corners might be, right? And lefts or rights, inside, outside. So we can unfold that as like a box. Just as a sketch though, we don't need to spend all the time, but if you want, draft it right out. But the sketch itself gives us a good indication. We can start putting some numbers to it and then easily transfer that to our blank sizes that we had. Okay, 4-piece transition.